One of the first revolutions was in radio. In the 1930s, the pioneering engineer Karl Jansky solved the problem of how to reduce noise in sensitive radio antenna and discovered the first radio signals coming from deep space. Among many bright and obvious sources like Jupiter the Crab Nebula and nearby galaxies, astronomers also discovered numerous small, faint, distant, point-like radio objects. These strange objects appeared all over the sky, emitted radio waves at a broad range of wavelengths, and could not be seen with visible or infrared telescopes. The only clue they gave was their position. They appeared both within the band of the Milky Way and outside of it. There are monsters out there, lurking in the dark. Since our galaxy is a thin disk, this meant that the sources either had to be extremely close, like the visible stars of the night sky, or extremely far away, like the distant galaxies. But if they were close, we should have been able to see them in optical wavelengths, and if they were extremely far away, their intensity in radio wavelengths implied they were the brightest objects in the entire universe. Understandably, many astronomers pushed back against this interpretation, not only arguing about their distance, but also openly questioning what could possibly power something that bright. They are the quasars, the most powerful engines in the known universe. But what drives these engines? What powers these lighthouses in the deep? The answer will take us on a journey through some of the most extreme physics in the universe and even provide us with a grim warning. For though our galaxy is quiet now, it will not stay that way forever. The most distant quasar from us is 13 billion light-years away. It would take nearly the entire history of the universe to travel to, and that's without the universe expanding at the same time. Space is big and getting bigger, and sometimes that can make us feel small. At first, astronomers had no idea what they were seeing. By the 1950s, science had grown used to the idea of galaxies outside the Milky Way. But even in this expanded cosmological view, the belief was that the universe was relatively small, only a few billion light-years across at most, and that expanded cosmos seemed relatively simple, even boring. There were galaxies, there were clusters of galaxies, there were vast expanses of nothingness. For a time, astronomers were able to convince themselves that they were finally starting to figure things out. But in the mid-20th century, there was a technological revolution. Optical telescopes capable of seeing objects in visible wavelengths of light were becoming enormous, and our ability to use the rest of the electromagnetic spectrum, wavelengths of light outside the visible, grew along with that. And with these new observations came the realization that the universe was far weirder than we could have ever imagined. For centuries, astronomers scanned the heavens again and again without ever spying them. But behind the familiar stars and nearby calm galaxies of our universe lay something far more vicious, far more terrible, and far more powerful. Completely invisible to the human eye, you would never see them even on the darkest of nights. Indeed, at first, they appeared as nothing but dim, distant pinpricks of strange radio emission. But those pinpricks revealed something no astronomer could ever have expected, something so strange, so bizarre that for years nobody even believed that they could exist, that there must have been some mistake in our observations. Thankfully, none are nearby, for if they were any closer they would flood our galaxy, our solar system, our planet with deadly radiation. A single one of these monsters can easily pump out over 10 to the power of 40 joules every second. For comparison, our sun outputs about 10 to the power of 34 joules, 1,000,000 times less every year. The brightest among them outshine stars, outshine galaxies, outshine 1,000 galaxies at once. Some extreme events, like the most powerful supernova, can briefly become brighter than these beacons, but those events are temporary, ephemeral, flaring and dimming in a matter of weeks. When these monsters awaken, they stay powered for millions of years. In just a fraction of their lifetime, they can easily produce more energy than even the most intense cosmic explosions, and they are hungry. They feed on anything and are capable of tearing apart entire stars in a single fit of rage, producing flashes of radiation and jets of charged particles that shoot out for millions of light years, piercing through galaxies and spreading their destruction throughout entire clusters. Finally, a breakthrough came in 1962. By the 1960s, astronomers had been able to refine the techniques of radio astronomy to the point they could more precisely measure the location on the sky of these strange sources. With these new techniques, astronomers Cyril Hazard and John Bolton found that one radio source, known as 3C273, would undergo occultations of the Moon, allowing them to provide an extremely accurate estimate of its position. Following up on that work, the Dutch-American astronomer Martin Schmid discovered a faint object in the same location in the visible spectrum. Within that visible light, Schmidt found a usual collection of bright spectral lines and dark gaps, the fingerprints of elements and molecules found throughout the cosmos. But these lines were not in their usual wavelengths. Instead, they were shifted towards the red end of the spectrum by nearly 16%. To get that kind of red shifting, either 3C273 had to be moving away from us at an incredibly fast speed, or it had to be incredibly far away. By this time, astronomers had been slowly accepting the Big Bang theory of the universe, the view that the cosmos was once smaller in the past and is continuing to grow in the present day. Under cosmological expansion, light from distant objects red shifts because the space between them and us expands, stretching the light out into longer wavelengths. And when he interpreted the red shifting of the light from 3C273, Schmidt realized it sat 3.4 billion light-years away. It was the most distant object by an order of magnitude ever observed. In 1966, Time magazine put Martin Schmidt on its cover, comparing the magnitude of his discovery to those of Galileo, saying the 17th-century Italian startled scientists and theologians alike. The 20th-century Dutchman has had an equally jarring effect on his own contemporaries. 3C273 was a revelation. It is so distant that it appears to us a simple, point-like object of incredible luminosity, in fact, making it another record breaker. It was also the brightest known object in astronomy at the time. And there are more details to it, which can be covered in the next part for you, so subscribe to our channel to stay tuned for all the updates. Also, don't forget to like and share this interesting theory with space enthusiasts. See you in the next interesting video.